Hi, Fountain 6. So I was hoping that we were going to be able to do this in person, but because we are remote, we're going to be doing this lab at home. So let's first read through the introduction of Testing Newton's Second Law. It says, imagine that you are a friend of Isaac Newton. He has been working feverishly on understanding the nature of motion and believes that he has used his knowledge to create a few laws that seem to explain how objects move. You are one of his most trusted friends and fellow scientists. He has developed a very systematic method of running his experiments, but he wants you to develop your own method to test whether his ideas are correct. One aspect of Isaac's explanation, which he calls his second law, can be summarized by the following equation: force equals mass times acceleration. If an object accelerates, it is because a force acts on it. Remember that acceleration means any change in speed or direction, which can be an increase or decrease in speed. The force exerted on an object is measured in newtons. As the amount of force placed on an object increases, its acceleration will also increase. So for the pre-lab question, you're going to test your calculations. You're going to be using this equation right in the background section to actually calculate force. So it says if an object has an acceleration of 4 meters per second squared and a mass of 25 kilograms, what force was applied to the object to get it moving? So I'm going to give you a minute. Please pause the video. Put your pre-lab question answer here. Make sure that you show your work. Set up your equation, and then you can use a calculator, and make sure your final answer has a unit. When you're ready, unpause the video, and we'll keep reading. So next is the scientific question in our perfect format. How does the mass of an object affect its acceleration? So you're going to fill in a hypothesis in our correct if, then, because statement. Let me first run through the procedure so that you know what you are hypothesizing about. We are going to take balls of 3 different masses. I've got a golf ball at home. I have a ping pong ball. I usually would do this with a marble in the classroom, but I don't have that. So instead, I actually have a paintball. You're going to be using any 3 balls that you have at home, any 3 round objects. If you don't have those, then I'll walk you through that in a minute. Now, we're going to be hitting all 3 balls, which have very different masses, with the same amount of force as best we can. And we want to see which one will accelerate the fastest. In this case, we're talking about an increase in speed. So your hypothesis is going to answer the question of how does the mass of an object affect its acceleration? I want you to think, as the mass of the object increases, as we go from the ping pong ball to the paintball to the golf ball, which is the most massive, how will its acceleration be affected? So take a minute, write your hypothesis in the correct format, and when you're ready, you can unpause. Okay, next we've got some variables. So we need our independent variable filled in, our dependent variable, and if you remember a little trick, you can actually find these from your scientific question. And we need 2 control variables. So take a minute to pause the video, fill those in, and then we'll take a look at the procedure. So if you look at the materials list, this is what we would need if we were doing this in school. I would need 2 rulers, 3 different balls. As I mentioned in school, I would use ping pong, golf, and a metal or marble ball. I would be using a meter stick. I would be using an iPad and a triple beam balance. I don't have all that stuff at home. I'm going to show you my at-home setup. If you have supplies that you can do your own at-home setup, then you can set it up yourself and you can do the lab on your own. If you don't have the supplies needed, then I'm going to do the lab on this video and you can collect data from this video. So let me get myself set up. The first thing I found was a ruler. I have a golf ball. I have a ping pong ball. I don't have a metal ball. So instead, as I mentioned, I have a paintball. Now, the first thing I want to do is actually find the mass of these 3 balls. I don't have a triple beam balance at home, but I do happen to have Google. So I did a little research and I found that the mass of a ping pong ball is 2.7 grams. So into my lab for a ping pong ball, I'm going to write 2.7. Now notice I don't need to write a G because it's already right here on my data table. So just 2.7 is good. I found the mass of a golf ball is 45.93. I'm going to round that to 45.9. And the paintball is 3 grams. No need to round there. So my paintball is 3 grams. I'm just going to do a decimal to keep it same with the rest. So now my setup. I'm going to stop sharing my screen for a second so I can show you my setup. So here's my desk. Now, I took my ruler and I measured from where I'm going to be hitting the ball, and I measured 50 centimeters. I know your lab says 100. My desk is not long enough for that, so I'm going to be hitting it 50 centimeters. So here's what I'm going to be doing. I'm going to start with the golf ball, my most massive ball. And 50 centimeters away from my finish line where I put my tape, and in this case, I even put a full piece of measuring tape to stop the balls. I'm gonna start my ruler. Let me see if I can get a good angle for you guys as these balls are rolling everywhere. So I'm gonna start my ruler and I'm gonna bend it back at an angle so that it kind of looks like a bat. And I'm gonna be flicking it. Let me show you a little sample one before I do a real one. So I'm gonna put my ball at my starting line, bend my ruler back, and actually flick it. Now here's gonna be your job. Your job is to start the timer when I say go, when I flick it, and stop the timer when I say stop and it hits this tape. I'm gonna reshare my screen to show you where this data goes. So right here, I'm gonna be doing a few trials. I'm first gonna actually do the golf ball, then the ping pong ball, then the paintball. You can see I'm actually changing this stuff as we go since we're all remote. So when I do trial 1, I'm gonna say go when your timer starts and stop when your timer stops. Whatever time you get, you're gonna put here for trial 1 for golf ball. I'll do it again and once more so that you have 3 trials for the golf ball. Then you're gonna be finding the average time. Remember, to do that, you're gonna add up these 3 numbers, click the equal sign in your calculator, and divide that number by 3. Then we'll do 3 trials with the ping pong ball, and 3 with the paintball. So I'm gonna stop sharing my screen so that you can see my whole desk on camera. Again, if you already have this set up at home, if you're able to do it at home, then you don't have to watch this piece. So let me get my setup going. I'm really just gonna, this might be a better angle. Sorry guys, learning as we're going here. Yeah, that's gonna be good. So now you can see where I'm actually starting from and when it hits here. So let me get my golf ball going. This is my most massive ball. Ready? 3, 2, 1, go. Stop. If you need to, you can always rewind if you didn't get that. Again, you're starting your timer when I say go and stopping either when it hits this tape, if you can see it, or when I say stop. So please put trial 1 right into your data table. Again, I'm just gonna show you whatever time you got is going right here. Trial 1 for golf ball. Okay, we're gonna do trial 2 for golf ball right here. So I'm gonna stop sharing so you can see my whole setup. Okay, 3, 2, 1, go. Stop. Okay, put that time in for trial 2. Line myself back up for trial 3. Okay, get your timer ready. 3, 2, 1, go. Stop. Okay, so at this point, you should have 3 times in here. Please pause the video and find the average time. And I'm gonna get myself set up for the ping pong ball. Okay. Oh wait, we're actually gonna do, so the next one I'm actually gonna do is gonna be the paintball because I'm trying to go in order of mass. And if we remember from above, the golf ball was the most massive, then the paintball, then the ping pong ball. So I'm going to do 3 trials with the paintball, just like we did before. When I say go, click go on your timer. When I say stop, stop it. And you're going to put your 3 times in here. So I'm going to stop sharing so that you can see my whole setup. I really hope this paintball doesn't open everywhere. Fingers crossed I don't make a mess. Okay, ready? Move my screen down. 3, 2, 1, go. Nope, it didn't go. It didn't move. It didn't move. You can see it hasn't moved. It's right here still. Okay, let's redo that. Get your timer ready. Okay. 3, 2, 1, go. Stop. Oh, that was so quick. Oh my gosh, that was so fast. You might have to rewind the video to get that time. Let's do it again. Oh my gosh. So fast. Okay. 3, 2, 1, go. Stop. Oh my gosh, so fast again. But it's not breaking, so that's good. Okay, one more trial. Here we go. 3, 2, 1, go. Stop. Oh my gosh. Oh God. Okay, that's gone. Okay, so at this point, please, you should have your 3 times in for the paintball. Pause the video, calculate your average time, and I'm going to get my ping pong ball set up. Okay, so now we're going to be doing the ping pong ball, which is our least massive ball. We're going to put the 3 times here and calculate the average, just like usual. I'm going to get my screen ready for you guys. Get your timer ready. Here we go. 3, 2, oh, it keeps rolling. Get your timer ready again. Here we go. 3, 2, 1, go. Stop. Oh my gosh, that was so quick. Okay, here we go. Okay. Timer ready? This ping pong ball is not staying in place like the others. Okay. 3, 2, 1, go. Stop. Wow, as soon as I said go, I had to say stop. That's how quick it went. Okay, last time. Let's get this ping pong ball in place. Okay, last trial. 3, 2, 1, go. Stop. Okay. Woo! That was quick. So let me reshare my screen. At this point, you should have 3 times for your ping pong ball also in, and should be calculating that average time. So I'm going to give you a minute, pause the video, calculate that average time. Okay, so I'm going to share my screen to show you how to do the next part. Again, I'm going to have to make just some minor edits as we go. So now that you have your average time, we actually need to calculate speed. Remember that speed is distance over time. And if you don't know, then don't worry, the equation is right here. Now, in this case, the distance that we're talking about is the distance that the ball traveled in centimeters, and the time is your average time from right here. So the first thing I would actually do is copy this set of your average time and paste it right here where it says time in seconds, because all that time is your average time. Now the distance traveled, I had wanted to do 100 centimeters, but remember I said that my distance was only 50. So I'm going to change these to 50 because that's how far the ball's traveled for mine. So let's do a sample one together, just as practice. So let's say that my average time for the golf ball from up here, let's say it was 1.2 seconds. Here's what I would do. I'm going to set it up. Into my calculator, I'm doing distance over time. So I would do 50 over 1.2. Let me grab my handy dandy calculator. See. So 50 divided by 1.2 equals, oh, I'm definitely rounding that. We're definitely rounding. As my directions say, I'm actually going to round to the nearest tenth, one decimal. So I'm going to say 41.7. Now notice I haven't been writing units in. I don't need to because they're already in the data table. So take your other two average times that you should have pasted right here, do your calculations, round them to one decimal, and that'll be your speed. I'm going to stop sharing for a second while you work on that. If you need more time, then please, of course, pause the video, but I'm going to move on to the next data table. So the next data table, share my screen again, this time we're calculating acceleration. So here's our equation for acceleration. Acceleration is speed over time. Again, I've got some stuff that I can use here. Your average time from above. Remember that column that you already pasted into this time column? Well, paste it here too. Let's continue to use our examples from above. Remember that my golf ball average in my example was 1.2 seconds. Remember that my speed, my average speed that I calculated here was 41.7. Notice that I took the speed I calculated right here and I simply pasted it here. You can do the same. I'm going to now do my acceleration. So let me get out my handy dandy calculator. And according to this equation, I'm going to do speed, which was 41.7 over time, which was 1.2 seconds. So let me get it out. Okay, my average acceleration was 34.75. Again, my units are all over the top of this table, so I don't need to rewrite them. Please take a moment and do your paintball and ping pong ball rows, and then we're going to move on to the next table. Okay, we've got one more table to do here. If you need a minute, please pause the video and unpause when you're ready. My last table is I want to calculate force. So I'm going to take my accelerations from right here, copy them, and just paste them. So notice I took my average acceleration of the golf ball. Now I'm going to take my masses. Remember at the very beginning, we found the mass of these three balls. I'm just going to copy those and paste them down here. So remember, we found that our mass of a golf ball was about 45.9. Now, if we remember our force equation from last week, amazing, it's in our note sheet. If not, I've got it right here. Force equals mass times acceleration. So in my calculator, I'm going to do mass, which is 45.9, times acceleration, which is 34.75 that you calculated in the previous table. And I'm going to plug that in. Let me get out my calculator. Ooh, that's big. And again, I'm going to round to the nearest tenth if needed. So I have found that my force is 1,595.025. So I'm just going to leave it as that whole number. That's it for these tables. So let's take a look. Please pause the video and finish this table. I'm going to stop sharing for a second, do a little erasing where I need, and then we'll take a look at the post-lab. Okay, I'm going to share my screen one more time. Let's take a look at the post-lab. So post-lab question number 1. It says an object has an acceleration of 6 meters per second squared. If the net force acting upon this object were doubled, if the force that this object is being pushed with doubled, I want to know what would happen to the acceleration. So we want to really look at this equation. Force is mass times acceleration. So if the force doubles, what happens to how quickly that object moves? I want you to think about the ping pong ball. If I hit this ball twice as hard, what would happen to its speed? So I want you to think about that and actually calculate the new acceleration. And then all we've got left is a claim, evidence, and reasoning conclusion. Remember that we should have one paragraph at the end. We don't want a claim section, evidence section, and reasoning. I definitely don't want any headers. If you need to separate it into 2 paragraphs, fine. But your final conclusion paragraph should go in this section of your sheet. So in the beginning, it says, how does mass relate to acceleration? In other words, what type of ball and the mass of that ball had the greatest acceleration? Was it the ball with the least mass or the greatest mass that had the greatest acceleration? And does this prove your hypothesis correct? Evidence, I need data, comparative data. So you've got to give me 2 pieces of evidence here. If I were you, I would give me the mass and the acceleration of the most massive ball, the mass and the acceleration of the least massive ball. To really show comparison, this evidence has to be in full sentences. You can't just list numbers. Any numbers that are included in these sentences need a unit, which would be grams for mass or meters per second squared for acceleration. Last question. According to Newton's second law of motion, why did your results occur? If you're up for a challenge, I've got one here. The challenge says, assuming that all the balls were hit with the same force each time, the forces calculated in data table number 5 should have all been the same. But if they weren't, I want you to think about what might have caused the difference. Again, challenges are optional. Whenever you're done, you can either share this Google Doc with me if that's easier, or submit it to Schoology. The Google Doc was great for me to be able to write comments for you guys, but if you prefer Schoology, I can do comments on that as well. Okay, if you guys have any questions, then please just let me know.